This is the screencast for section 4.8, example 5. In examples 5 and 6, we're going to study harmonic motion. There are a lot of things in the world that have a repeated motion, and we can model those motions using a sine curve or a cosine curve because of the pattern of a sine or cosine function. So the first one we're going to do in example 5 is a piston, and how the piston condenses and retracts to turn a wheel, and we're going to use cosine to model that. We can also use sine to model harmonic motion, but we're going to use that for a stretching spring. And the reason why we would use sine for a stretching spring is because a spring is at rest at position 0 when it isn't stretched or isn't condensed at all. So we want the origin, the function, to go through the origin for a spring, whereas a piston gets most of its momentum when it is fully stretched out, and then it would condense the full way. So we want a piston to start not at position 0. So we're going to use cosine to model its harmonic motion. So example 5 says, in a mechanical linkage like the one shown in figure 4.94, a wheel with an 8 centimeter radius turns with an angular velocity of 8 pi radians per second. So basically, you have this piston condensing every time the motion occurs. What is the frequency of the piston? Well, frequency by definition is the number of oscillations per 1 unit of time. This problem gives us that the object rotates at 8 pi radians per second. Well, I know from my study of the unit circle and radians in general that 8 pi radians is 4 full rotations. So this will do 4 oscillations in 1 second. So that is the frequency, 4. Now, part B. What is the distance from the starting position t equals 0, exactly 3.45 seconds after starting? So we are trying to look for the difference between positions at t equals 0 and t equals 3.45. So we've got to come up with a function to model how this object is moving. Well, first of all, your book gives you a formula up here. Frequency is W over 2 pi. Well, I know that the frequency is 4. So if I multiply both sides by 2 pi, I get W equals 8 pi. Look familiar? That is the number of radians in 1 second. So W is essentially radians in 1 second, or 1 unit of time. Now, this wheel has a 8 centimeter radius. That will be our A value. Just like the sine curve will stretch from 1 to -1, this wheel, if it's got an 8 centimeter radius, will push the piston 8 to -8. So I'm going to change the amplitude of this sine curve to 8, which means the A value is 8. So 8 times, I'm sorry, we're using cosine, of 8 pi t. So now the distance from starting position to 3.45 seconds is, we're going to take the absolute value, because depending on which one's further or closer, we don't want a negative value, we're just looking for a distance which is positive. 8 times the cosine of 8 pi at time 0 minus 8 times the cosine of 8 pi at time 3.45. Absolute value. And then in my calculator, I'm going to be in radian mode because I am using radians, unlike the previous examples. I get the position at time 0 is 8 minus 2.47. Turns out we don't have to worry about the absolute value, that'll be positive anyway. But we get 5.53 centimeters. The now try problem, number 27, is a very similar situation, just with different numbers. So we are still going to use the cosine formula. This wheel has a radius of 6 inches and turns with an angular velocity of 16 pi radians per second. So what is the frequency of the position? The frequency is going to be, let's see, they gave us 16 pi radians per second. I want to know how many rotations per second. 16 pi is 8 rotations, 2 pi per rotation, so it's 8 rotations per second. So the frequency is 8. What equation models the motion of this piston? Well, we know that W is going to be 16 pi from understanding what W was in the previous example. We know W is the number of radians per second, so that is 16 pi. The radius of this piston is 6, so that's going to be our amplitude of this particular cosine function. And so y equals 6 times the cosine of 16 pi times x. What is the distance from the initial position? Here we go again, 2.85 seconds after starting. So the distance is going to be the absolute value of 6 times the cosine of 16 pi times 0 minus 6 times the cosine of 16 pi times 2.85 seconds. So we're finding the difference between the distance at time 0 and the distance at time 2.85. And let's see, in the calculator, that's about 6 minus 1.85. Again, we don't really have to worry about the absolute value in this one. Turns out it will be positive. But we get 4.15 inches.